Right similar triangles formed by dropping an altitude from the right angle of the triangle. The goal of this tutorial is to be able to find the side length of one of the many triangles formed in this situation. For instance, you can look at the three triangles on the screen here. We'll get to them later, but we want to be able to find out the value of x, whether it's this side or this little side here or out here. And this tutorial can be found on our website, mathwarehouse.com/gm, where you can find many other practice problems if you would like more practice. Also, this is sponsored by painfreehomework.com, where you can get your homework answers pain-free. So if you're ever stumped on this topic or others, feel free to visit Pain-Free Homework and post your question there. Okay, well, let's start the tutorial by creating an altitude. Let's start with a right triangle, which you can see here. We know it's a right triangle because it has this right angle here. And to create the kind of problems that we're talking about today, all you do is you start at the vertex of the right angle and you drop an altitude. Go straight down. Right, an altitude intersects the far side at 90 degrees. And look, we've got voila, we have three triangles actually. We have the little triangle on the left, the medium-sized triangle on the right, and the giant outer triangle. It turns out that all of these triangles are similar. If you remember something about similar triangles, they have congruent angles. And we can see that that would be true if we make up some measurements for the angles. Let's say that this angle measures 30 degrees. All right, so the right triangle measures 30, and then it's got a 90-degree angle here. And let's think about how big would this angle be. Well, if this is 30, this is 90. We would be left with 60 here. And then let's look at the little left side triangle. If we think about the giant outer triangle, we've got 30 here, we've got the right angle here, and that would leave us 60 here. So the giant outer right triangle has a 60-degree angle, a 90-degree angle, a 30-degree angle. The right side triangle has the same thing, 30, 60, 90. And now let's look at the left triangle. 60 here, 90 there, 30 here. I don't know if those are the exact measurements of these angles, but you can see that we do actually end up with similar triangles whenever we drop an altitude from the hypotenuse of a right triangle. And here's a demonstration that will show you what happens if you were to reorient all of the triangles. Let's put the little triangle this way, let's put the medium triangle this way, and let's switch around, boom, boom, the large triangle this way. This is a demonstration that's on the webpage, mathwarehouse.com/gm, that I was referring to. Now, if you remember, similar triangles have equal angles, and they also have proportional sides. Meaning, I can set up a proportion with corresponding sides. So if I talk about this R to this H, the little side of this left-hand triangle to the altitude, it will be proportional to H over S. Right? R over H equals H over S. And that is what is so neat about when you drop this altitude. Not only does it create three similar triangles, the giant outer one, the right-hand medium one, and the left-hand small one, but it also lets you set up proportions that involve the same side length. H here. H is in both of the proportion, in both sides of the proportion here. And just to recap, the R over H equals H over S is simply us using what we know about similar triangles, which is that their corresponding sides are proportional. So R over H, little triangle, equals H over S. So that's going to lead us to be able to do many kinds of problems that high school students often have to answer. Okay, one of the most common problem types look like the ones on the screen here. We've got 3, 9, and these are sides in the little triangles. And I'm always going to refer to the little triangles as having sides. So we've got a side of 3 and a side of 9 here, and we're trying to find the altitude. We've got a side of 2, a side of 8, and we're trying to find the altitude x here. So this is one of the classic problem types that students have to deal with. Now let's think about what we saw in the prior demonstration here. We saw that r over h equals h over s. So little side to altitude equals altitude to the other side. In fact, that's one of the core formulas I would recommend you just memorize or get really comfortable with. SAAS, side over altitude equals altitude over side. In the triangle on the left, SAAS, side over altitude, altitude side, equals 3 over h equals h over 9, because the altitude is h, and the one side that we know about is 3, the other side is 9, and they're these sides are the two parts of the large hypotenuse of the total outer triangle. So in general, I would say step 1 is to set up the proportion. Let me try to write this more neatly, and there's not much space here. So set up the proportion. If you see this kind of situation, it's side over altitude equals altitude over side. Step 2 is to solve. Alright, we just want to solve for h. And that means we have to cross multiply. 9 times 3 is 27. And it is h squared. Alright, to finish up the solution here, h equals the square root of 27. And if you wanted to write this in simplest radical form, remember this would be 3 root 3. Alright, so just a quick recap before we try another problem like the one on the right. When you are dealing with this, and this, these are the two sides that make up the large outer triangle's hypotenuse, and the altitude itself. Use SAAS, side over altitude, altitude over side. 3 over h equals h over 9. And then solve. And actually that is different. I just want to draw a contrast to it. Notice this is a different kind of problem, and we're going to come up with a different formula for that. But I just want to, these are actually different. I think I said they were the same earlier. I put the wrong picture. This is a different kind of problem, but it's worth contrasting. We're going to come up with a way of solving these kind of problems, but I want to it's good right now actually to kind of contrast them. The difference on the right is we're not dealing simply with side, altitude, side. We're dealing with side, side, and then a leg of the giant outer triangle. Again, what I mean by side versus leg is when I use leg, I'll be talking about the giant outer triangle's leg. When I use side, I'm talking about a little side of one of the inner triangles, a leg of the inner triangle. Alright, so let's look at another triangle and try to use SAAS. Okay, I just added a new triangle on the right here, and I came up with some side lengths. Hopefully they're somewhat to scale, but let's not worry about them being perfect. Let's say that JI is 2, GI is 7, and IH is x, and we want to find x. Well, hopefully you recognize this as dealing with the exact same sides as our prior triangle. It deals with a side, and the altitude, SAAS. So let's set up our proportion, SAAS. So it's going to be S, or 2, over the altitude A equals the altitude A, or 7, over x. So you know the deal from here. We're simply going to solve by cross-multiplying, so you end up with 2x equals 49, and x equals 49 over 2, or 24.5. Okay, so this is it. This is one of the two core problem types you have to deal with: side altitude, side, and that's how you solve it. Okay, the other type of classic problem type can be seen in all three of the triangles here. And let's first off try to see, why is this not a side altitude side problem? Do you see what is not involved in these problems here? Hopefully you see that the altitude has nothing to do with this problem. It's not something that we're given, and it's not something that we're trying to find. Basically, we don't care about the altitude in this kind of problem. What do we care about? Well, we care about the hypotenuse of the outer triangle. Notice this is the hypotenuse. 8 plus 2 is 10. The hypotenuse is x here. The hypotenuse is 13 here. We also care about a leg of the giant outer triangle. And we're also dealing with a side, 33, 8x of one of the inner triangles. And this will be known as HLLS to help us remember that the formula in this case is hypotenuse of giant outer triangle, leg of outer triangle, and side. And just to recap, whenever I use leg or hypotenuse, I'm talking about the giant outer triangle. Like the hypotenuse is 13 here, the hypotenuse is 10, the hypotenuse is x. When I use side, like here, I'm talking about, the little sides of the inner triangle. And leg, of course, is a leg of the outer triangle. Like, what's a leg of this outer triangle? It's 5. And it's 36. Now let's look at a picture that shows you how hypotenuse leg side, HLLS, really does set up a set of corresponding sides of similar triangles. Let's look at this triangle here. 5, 13, we're trying to find x, and HLLS says that hypotenuse, or 13, right, is the giant outer triangle over its leg of 5, matches or corresponds with 5, or the hypotenuse of the little triangle, over x. So again, this picture here is just to show you that we're really just using our similar triangles definition. If you reorient all these triangles and set them up so they're in the same, they're facing the same way, you'll see that 13 over 5 goes with 5 over x. And let's say the problem was a little different and we were trying to find this part, x, and this leg of the giant outer triangle. Then hypotenuse leg side would say 13 over 12 goes with 12 over x. Alright? So this picture here is just to show you that HLLS simply goes back to the main definition of similar triangles, which is that their corresponding sides, 13, 5, 5x, or in this case 13, 12, 12x, are proportional and can be set equal. Pretty much any problem involving right similar triangles can be solved with either SAAS or HLLS. Sorry, that thing there is supposed to be an A in the middle. SAAS or HLLS. The first set that we looked at and this second set. So let's try to solve some of these without looking at the picture. Let's set up the proportions. HLLS. Right? What is let me write it this way. What is HLLS in this? Well, in this case, the hypotenuse, remember we mean the hypotenuse of the giant outer triangle over the leg, 5, equals the leg 5 over the side x. So it always, the side that we're talking about is always the one that's right next to the leg. So it's 13 over 5 equals 5 over x. Or in this case here, what's the hypotenuse? The hypotenuse is 10 over the leg equals the leg over the side. So remember, the leg is the outer triangle here. We're talking about either x or this guy. So hypotenuse over the leg equals leg over. So students often wonder, well, what do we mean by side? The side could either be 2 or 8. Remember, side refers to the little triangles inside. And the side always is right next to the leg we're talking about. So if the leg is x, the side is 8. Hypotenuse, leg, side. Let's try it again here. Let's try to identify in these triangles. Here, in these triangles. What's the hypotenuse? Hypotenuse of the giant outer triangle is x. What is the leg? Remember, leg is what we're talking about in the part of the giant outer triangle, so it's 36 equals leg 36 over side 33. Remember, the side is always right next to the leg. So if the leg is here, the side is there. If the leg is here, the side is 8. It's not 2, because 2 is far away from the leg that we're dealing with. And again, just to remind you, HLLS just goes back to these similar triangles, and if you match up their corresponding sides, the proportions always work out this way. Alright, once you get the proportion set up, it's just like the prior problem. You simply, for all of these, you simply cross multiply and solve. Right? Cross multiply, solve. Maybe we'll do 1 together. I mean, we'll just say, 80 equals x squared, and x equals the square root of 80, which you can simplify if you want. I'm mainly interested in helping you solve these right similar triangle problems, and the new thing for people learning this is how do you set up these proportions. So it's always either side angles, angle side, or hypotenuse leg, leg side. Okay, I'd like us to practice 3 more triangles before we look at some challenge problems. The goal of these 3 is I just want us to be able to set up the proportions as either side, altitude, altitude, side situation, or hypotenuse, leg, leg, side. So let's look at these 3 triangles here, try to set up the proportion, and we won't solve it. You can, I'm trusting that that's something that you can do on your own. And let's say that we've got this real world situation with the picture depicted on the left where we've got a brick wall and we've got a ladder leaning against it. The ladder's 24 feet long. We know that this section is 10 and that we want to find x here. You want to find the altitude here. Well, notice what we're dealing with is the altitude, the side, and they gave us the whole hypotenuse here, but since this is 10 and this is 24, we can figure out that this part here is 14. So do you see it now? It's going to be side, altitude, altitude, side. Right? Side 14, altitude x equals altitude x over 10. Cross multiply and solve. Alright, so here's another problem where we've got a little more information than we need, and we're trying to find x here. Hopefully you're starting to pick up. If they give us x, or if we're trying to find the altitude, you've got to do side, altitude, altitude, side. So we know we can just fill in for the altitude. What's that? It's x. And what are the sides? 5 and 13. So this 9 is just extraneous. We just don't need it. It's just kind of, you'll sometimes get problems where you've got some extra information that you don't need to know, and it's up to you to decide and to recognize that in this situation, the relevant information is the altitude and the 2 sides. Here we've got a 44, a 22, a 70, and we're trying to find x. And let's think, which would you use? Well, since this problem does not involve the altitude, I hope you got a hunch that it's going to be hypotenuse, leg, leg, side. What's the hypotenuse of the giant outer triangle? It's 70 plus 22. So the hypotenuse is 92 over the leg and the side, right? So now notice, we do know out here, we do know this leg 44, and we're trying to find this leg x. So which do we choose? Do we choose x and 70 or 44 and 22? Well, since we're trying to find x, you might have guessed it, we need to do x and 70. Remember, the leg and the side always go with each other. Again, I just made these numbers up, so I am not totally sure that they would work out if you actually drew these triangles out, but I would just want you to be able to see how you can set up the proportions to solve this kind of triangle. Okay. Now let's try a more advanced problem. Okay, let me fit this on the screen. Okay, so this problem is a little bit more of a doozy. Our goal is to find the altitude, h, right? So hopefully immediately you're thinking, oh, we're talking side altitude, altitude side. But let's see what happens when we try to do that. Side altitude, altitude side would mean b over h equals h over a. Yeah, that's not very helpful, listen, because we've got 3 variables in an equation, so can't do much. If we could figure out a, we could also figure out b, since we know the whole hypotenuse is 5. So one way, and there are quicker ways actually, but one way, if we're going to stick to SAAS and HLLS, is to first see how we could use this formula to get either b or a. Well, we know the hypotenuse is 5, and let's look at 4 as a leg. 5 over 4 equals 4 over, well, what side would go with 4? The close one next to it, a. And we can now cross multiply and solve for a. Right, a equals 16 over 5, which will give you 3.2. Alright, so now we know that a is 3.2, and we can also figure out b, because b plus a is 5. So b is going to be 1.8. Now, let's think about what we have. We have b and a, and we want to find h, which was the goal of our problem. So now we can use our 2 values for b and a, and just substitute them in here, and solve like normal. So b, or 1.8 over h, equals h over 3.2. h squared equals 1.8 times 3.2, which gives you 5.76. Now to find h, we're just going to take the square root of 5.76. And that'll give you 2.4. So h equals the square root of 5.76, or 2.4. So as you can see, sometimes these problems can get kind of complicated. Side altitude, altitude side, and hypotenuse leg, leg side can solve, I think, pretty much any problem. However, I want to point out there actually is a way to do this problem much quicker. If you want a steadfast way to solve all the problems, SAAS and HLLS always work. However, in this one you can actually sort of reorient the triangles and see that h over 4, that's the small leg of the triangle. If we're talking about the right triangle, it's the h over 4 equals 3 over 5. And if you took this giant outer triangle and switched it all around, you would have this little leg 3 here and the hypotenuse 5. So we're just saying h over 4 equals 3 over 5. And you would see that 3 over 5 times 4 also equals 2.4. So you can always use these similar triangles to solve these problems if you want to do it a little quicker. SAAS, HLLS always does the job in a way that you can rely upon. But keep in mind that there are sometimes shorter ways of doing things, like here, which is using the same idea, similar triangles, to look at corresponding sides. Okay, let's wrap it up with another problem like the prior one. If you can do a problem like these, you are a pro at right similar triangles. Alright, so we've got a 14, 48, 50 right triangle with an altitude h, a segment A, a side A, a side B, and we want to find this altitude. And so you might recognize this is the same dilemma as the last problem, right? When we're trying to find the altitude, so you probably are naturally thinking side, altitude, altitude, side. When we set that up, you get A over H equals H over B, and again, an equation with no known value. But we can use that formula in conjunction with hypotenuse, leg, leg, side to do something. Right? Hypotenuse of the giant outer triangle is 50, and let's deal with the 48 leg. Leg 48 equals leg 48 over side A. And just for thoroughness' sake, you could have also worked with 14. You could have said 50 over 14 equals 14 over B and solve for B. You'll end up getting the same answer that we're going to get right now. We're going to cross multiply to get 50A equals 48 squared, and A equals 48 squared over 50, or 46.08. So since that's the value of A, it's pretty easy to figure out what B is. B is just 50 minus 46.08, or 3.92. Now we can use SAAS by saying I'll write it closer to the formula, 46.08 over H equals H over 3.92. Alright, and you can cross multiply and solve like we've done before. I won't do that now. Okay, that's pretty much all I have to say about solving for side lengths of right similar triangles. If you'd like more practice problems, feel free to visit mathwarehouse.com/GM. There's several other practice problems presented in a PowerPoint style format on that page. And don't forget, if you're stumped on your homework, visit painfreehomework.com and post your questions to get answers from teachers and tutors. Thank you.